about liquids. Now we're going to talk about gases. Alright, let's talk about behavior of gases. I'm on page 96. Yeah. Yes, sir. Gases. Talk about their behavior. Alright, they fill their container. Oh. Maybe we should not be here.
What page is it?
Page 96 is where I'm starting. These are for your notes. This marker is not.
Are we doing the review as well?
See.
Alright.
I mean, yes. Okay, they fill the container. Trying to spell this correctly. Excerpt. Okay, so they fill the container, they exert pressure on its container, and it can be compressed. You can actually change the volume. If you compress it, though, it does change the amount of pressure that's in there. For example, if I blow up a balloon, you can still sit on the balloon, not an issue, but it does build pressure in there. And if you put too much pressure on there, it's going to break the membrane, and your gas is going to escape that. And there's going to be a lot of pop on board, so it works. All right, we have these things that are called gas laws. Do you guys remember what a law is? Talk about scientific laws, scientific theories. What's a law?
He said rule.
It's a rule. It's something, it tells us how things relate, okay? First law we're going to start off is called Boyle's Law. Boyle's law says for a fixed amount of gas at a constant temperature, the volume of the gas increases as the temperature, the gas pressure decreases. Likewise, the volume of gas increases as the gas pressure increases. Right? That is what we use for his law. Pressure 1 times volume 1 equals pressure 2 times volume 2. That's the formula. These are really nice formulas. I will be giving you guys, not today, but tomorrow we will be doing some actual math with these. Today we're just dealing with concepts. All right, that's the good news. They included this, they included Charles' laws. All right, Gay-Lussac's law. Sure I spelled his name correctly. All right, Gay-Lussac says that the pressure of a gas increases as the temperature increases. The pressure of, if the volume of the gas does not change, okay? So this one, temperature stays the same. This one, the volume stays the same. That makes sense so far? Maybe I should put that. Temp constant. This is volume. All right, so we write his law this way. P1 over T1 equals P2 over T2. Okay, last one we have on these guys, Charles' law. And I always want to put E before L, but it's not. Any guess what Charles' law deals with? Yeah, the pressure's going to be constant. Okay, so far we have temperature constant, volume constant, now it's pressure constant. Okay, so according to Charles, for a fixed amount of gas at a constant pressure, the volume of the gas increases as the temperature increases. Bless you. Likewise, the volume decreases as the temperature decreases. How many of you guys have ever put a balloon in a refrigerator or a freezer? Have you done that?
Water balloon.
Water balloons don't count because they actually expand. Because water, when it freezes, it expands. But no, if you take a balloon filled with air and stick it in the freezer, and you come back an hour or two later, you're going to find that the balloon itself has shrunk. It's kind of cool. It's because, literally cool, because the air, as it gets colder, shrinks in volume. So, the way he wrote this one is V1 over T1 equals V2 over T2. I just realized I missed a few pieces on this one. Do you guys have space to add some things here? No? Okay, so you have to do it as a PS. I just realized I missed some pieces. They expand to fill the container, they spread out easily and mix with each other. I didn't include that one. So fill container, spread and mix easily. They will have low densities and are mostly empty space.
What did you guys say? You just said that she forgot the letter D. Just when I heard like 20 people say that you forgot the letter D after C.
A, B, C, D, you're correct, and then E. Thank you. Appreciate the correction. All right. So those are two pieces I missed. Fills container, exerts pressure on the container. They can be compressed, spread, and mixes easily. They have low densities and are mostly space. Right, any questions on this? By the way, we do have a law that allows us to combine these. It's called the combined gas law. Let me give it to you guys now. You notice something that these all have in common? They all have pressure, temperature, and volume. All right, so this is how we do it. For combined gas law, we just say it's P1 V1 over T1 equals P2 V2 over T2. That's our combined gas law. That way, you don't have to memorize Boyle's law, Cayley-Six's law, and Charles' law separate. You can use the combined gas law. You just need to remember if it's constant, you remove it from the equation. So if volume is constant, you have P1 over T1 equals P2 over T2. You ignore the V's. If pressure is constant, you have V1 over T1, V2 over T2, because you ignore the P's. If temperature is constant, you've got P1 V1 equals P2 V2, you ignore the T's. You get the idea. So this actually allows us to pull out each one of these laws just out of here, as long as we can ignore the constant. Does that help? So the only one you guys really need to know and memorize would be this one right here. Those are next to it. Okay? Are there any questions on this so far? Friday? All right, I would like you guys to do a section review on page 104. I would like you only to do 1 to 9. Please do not do 10 tonight. Page 101. 1 to 9. All right, tomorrow we will have the math behind it. So we'll actually get to do Boyle's law, Cayley-Six's law, Charles' law, and the combined gas law. We'll do that tomorrow. Does that make sense? We'll spread over a couple days, so you guys don't overwhelmed with it. Which means Friday we should be having a lab dealing with gas laws. Because we're going to be doing quite a few things with balloons. Yes,
Do you
ma'am?
want us to turn in our notes?
No, you get to keep your notes. That's, remember, you study them for the next day for the quiz. Okay? So tomorrow I want to know, I'll probably put the behaviors of gas laws, behaviors of gas and the gas laws, those will be on there. And then I'll have a thought question for you for stage 4. All right, any questions? I'll leave you to it.